So, hi everyone, welcome to my channel. So, last time, we managed to solve half of Wbslst, this type of half of Wbslst 2025 physics questions. But I had to pause there. Now I am here, and in this video we will finish the remaining questions. Okay, and let's start step by step. I will solve this question is in details. Okay, so start. So the question is: a liquid with coefficient of volume expansivity gamma is filled with a container of material having coefficient of linear expansion alpha, and if the liquid overflows on heating, then these four options. So question is given: a liquid coefficient of volume expansion of the liquid is gamma. Okay, this is gamma, and each liquid is placed in a container of material which coefficient of linear expansion is alpha. And for solid, this is the question from class 10. Okay, class 10 I think. From solid we know, if for solid it's linear expansion alpha and areal expansion beta and volume expansion is gamma. I think it's gamma prime. I'm written not to look like this. This is volume expansivity gamma, areal expansion beta, and if linear expansion of a solid is alpha, then the relation of the for these three alpha beta gamma prime is alpha is equal to beta by 2 is equal to gamma prime by 3. Okay, so from this equation we can say that the volume expansion of the solid material gamma prime is equal to 3 alpha, 3 times linear expansion of the solid material. Okay, and question is asked that if the liquid overflows, means when the material is heating, when the material having coefficient, if the liquid overflows on heating. Okay, after heating liquid overflows. Okay, so the volume expansion of the liquid should be greater than volume expansion of the solid, because after heating liquid overflows. Okay, after heating liquid overflows, so this gamma will be greater than gamma prime. Okay, and gamma prime is equal to 3 alpha, so gamma will be greater than 3 alpha. So this option B is the correct. Okay, so the easy question: after heating liquid overflows means the volume expansion of the liquid is greater than volume expansion of the solid material within which container the liquid is placed. Okay, next question. So a car turns a corner of a slippery road at constant speed of 12 meters per second. If the coefficient of friction between the road and wheel is 0.4, the minimum radius of the arc in meter in which car turns. Okay, so this is this type of when a car turns a slippery road. The road is slippery and constant speed 12 meters per second. For taking turns for the car needed centripetal force. Okay, for circular motion car needs centripetal force. Centripetal, not centrifugal, centripetal force, and this centripetal force is provided by frictional force between the tires and the road. Okay, this centripetal force is this mv square by r is the radius of the arc. Question we have to find the radius of the arc. Okay, this centripetal force is the mv square by r. Without this centripetal force car cannot move in a circular path. Okay, and this centripetal force is provided by frictional force between the car and between the wheels or tires and the road. Okay, and frictional force between the tires and the road is F is equal to mu mg. Mu is coefficient of friction into mg, and coefficient of friction is 0.4, and m is the mass of the car and g is the gravitational acceleration, and minimum radius. And we know that for not skidding, in this case for not skidding, the condition for not skidding is the centripetal force always less or equal to the maximum frictional force between the tires and the road. Okay, so not for not skidding, the condition mv square by r less than mu mg, so mm cancel out, so we have to find minimum radius. So so minimum radius r is equal to v square by mu g. So v square, v is equal to given the 12 meter and mu 12 whole square means 144 and mu is equal to 0.4. Okay, so mu is equal to 0.4 and g is equal to 10. So this is 36 meter. Okay, radius of the arc, minimum radius of the arc 36 meter, and it is the condition for not skidding. Centripetal force always less or equal to maximum frictional force between the tires and road. Okay, and for car, the basic concept that car for moving a circular path needs centripetal force, and who provides this centripetal force? This frictional force between tires and road provides the centripetal force. Okay, good. So next question, a ring shaped piece of metal is heated. If it expands, then size of the hole of the ring would. Okay, I think options are the size of the or present, the size of the ring extend or contract, this type of. Okay, options are present. If ring shaped piece of metal is heated, so ring shaped piece of metal is heated means its circumference increases. So now its circumference will be big. Okay, circumference. If firstly ring circumference is 2 pi r, now circumference 2 pi r prime, r where r prime greater than r. Okay, the circumference increases. So this is one basic concept that if circumference increases, the size of the hole of the ring also increases. Okay, I think this type of options present. Okay. Okay, then the temperature of an ideal black body becomes half of its original temperature. Okay, and the amount of radiation emitted by the body will reduce by a factor. Okay, we always know that for black body radiation, the radiation emitted by the black body from Stephen's law, P, radiation emitted per unit area per unit time, P is equal to sigma T to the power 4. Sigma is the Stephen Boltzmann constant. Okay, and if temperature of the black body is half of its original temperature, so P prime is sigma TF. If this is TI, TF will be TI by 2, because they give the half of original temperature. If temperature becomes the half of original temperature, the amount of radiation emitted. So this is nothing but P by 2 to the power 4 means 16. Okay, from Stephen Boltzmann formula we have to remember this formula, power law, T to the power 4 power law, and sigma is the constant. So amount of radiation emitted by the body will reduce by a factor of 1 by 16. Okay, then next question, when a path of light ray changes from one medium to another, the physical property that remains unchanged: velocity, wavelength, frequency, refractive index. So we always know that when light passes from one medium to another medium, velocity always changes, and refractive index of two medium always different. So this is also different. Wavelength also different, but frequency remains fixed. Frequency when light passes from one medium to another medium, like this way. If this is the glass, okay, sorry, this is glass. Sorry. Wait. This medium is air. Okay, this medium is air, and this is the glass. Here velocity of light two medium is different because the refractive index of two medium is different. Wavelength is also different, but frequency when light passes from one medium to another medium, frequency remains same. Okay, so frequency remains same. Very easy and good question. When path of light ray changes from one medium to another medium, the physical properties that remain unchanged. This is frequency. Okay, good. Which of the following represents the correct order of electron affinity? Okay, this is questions. Correct order electron affinity. We know that from this all are 17 group of periodic table. Fluorine, chlorine. I think like this way. Fluorine, chlorine, bromine, iodine. Right? And electron affinity or electron attractive power, I think in this way, na? Electron attractive power, first fluorine, then chlorine, then bromine, then iodine. Along the line, this electron affinity reduces, na? So C will be option. Fluorine, then greater than chlorine, greater than bromine, greater than iodine. Electron affinity. These are class 10 question level questions. Okay, next. So a ray of light passes through a equilateral prism in such a way that angle of incidence is equal to angle of emergence. Okay, firstly, this is the equilateral prism. This is the ray diagram. Okay. This is I1, this is I2, angle of incidence equal to angle. Okay, this is I1 is the angle of incidence and this I2 is the angle of emergence. Okay, and this is the deflection, angle of deviation, angle of deviation. If angle of incidence is equal to angle of emergence, okay, so I1 is equal to I2, angle of incidence equal to angle of emergence. And if angle of emergence is 3/4 of the angle of prism, okay, if the prism is A, B and this is C, okay, angle of emergence is 3/4 of angle of prism, means angle of prism means I1 I2 is equal to 3/4 into A, and this is equilateral triangular prism, so the A is the 60 degree, okay, and the angle of deviation. So from formula we know that delta deviation is equal to I1 plus I2 minus A, and I1 I2 same, so 2 I1 minus A, so 2 3/4 into A, 3/4 A, so this is 3/2, this is A by 2, okay, and A is a 60 degree, so this is 30 degree, okay, so angle of deviation is equal to 30 degree. Good. This is class 10, just we have to remember the formula, okay, just I1 plus I2 minus A, and always there is another question when angle of deviation will be minimum, when I1 is equal to I2, okay. Maybe next time this type of questions they can be, okay, when angle of deviation will be minimum, the condition is when I1 is equal to I2, okay. They can next time ask also this type of question. So the radioactive nucleus 13 and decays to this by emission of this, okay. So 1 second. So this is first 13(7N). So proton is 7, neutron is 6 in this element, and second element 13C6, here proton is 6, neutron is 7. So radioactive nucleus decays to this, okay. So we see that mass number remain fixed, okay, and here one proton is reduced and here one neutron is increased, okay. So it decays to by, okay, this nucleus decay to this nucleus by emission of this. So we know that proton is inside the nucleus can decay into neutron plus positron. Okay, so one proton converted into neutron, so proton is reduced by 1 and neutron is increased by 1, and this positron inside the nucleus, so neutron inside the nucleus remain present but positron emitted, positron is emitted from the nucleus, so decays to emission of positron. Answer will be positron. Okay, this is interesting question. How to solve this? Just we have to calculate the proton and neutron number. Here proton number 7, here neutron number 6, here proton number 6, neutron number 7. So one proton is converted to neutron, and so proton is reduced by 1 and 1 neutron is increased here. So here one proton is converted to neutron, and we know that when proton converted to neutron, also a positron is emitted from the nucleus. Okay, so emission of positron will be answer. Good. And next question, the half-life of radium is 1600 years, and after 400 years, what fraction one of radium sample would remain unchanged? Okay, so half-life time is given 600 years, and after time is 400 years, what fraction of radium sample would be remain unchanged? N0. So this is the formula. Okay, N0 is the number of radium sample at T is equal to 0. Number of radium sample at T is equal to 0, and this N, when at T is equal to time, number of radium sample remains at T is equal to T at time T. Okay, so what fraction of radium sample remain unchanged, we have to find it. So like gamma is equal to, you know that this is ln2 by T half. T half is 100 600, and T is 6400. Okay, so just replace this. So this is 4, and we know that gamma is this, we know, everyone know that gamma is 0.693 by T half, and 0.693 you can call it ln2, and this is T half. So this is N0, this is ln to the power 4, and this is 0 ln 1 by 2 to the power of 4, and we know that if e to the power ln x means x, this type of form, e to the power ln x to the power a means x to the power a. So from this formula, we know, everyone know this formula, and from this formula we know that this is N0 and this is 1 by 16. Okay, so the question is, what fraction of radium sample would remain unchanged? So at T is equal to 0, this number of radium sample N0, and T is equal to 6400 years. After 6400 years, number of radium sample would be 1 by 16 of the N0. Okay, good. Just this formula you have to use, N is equal to M0 to the power minus lambda. Very easy question. Just we have to remember this formula. Okay, a light body of a heavy, the question is, a light body and heavy body have equal kinetic energy, so which one has greater linear momentum? Okay, kinetic energy same, two bodies, and which are linear momentum. Very easy question is this, because if kinetic energy is same, we know that kinetic energy Ek is equal to p square by 2m. For two body, Ek is the remain same, so p square proportional to m, and for this case p proportional to root over m. If m is high, p is high. If m is low, p is low. For same kinetic energy, linear momentum of the heavy particle will be higher, and linear momentum of the lighter particle will be lower. Okay, because kinetic energy of them remains same. As the question is given, kinetic energy of two bodies same. So when kinetic energy two bodies same, so which one of the greater linear momentum? So which has a heavy body, which is heavy, particular heavy body has greater linear momentum. Na? Okay, so good. From formula, just formula this. From formula we can solve this. So 3 2 ohm resistors are connected to form a triangle. The equivalent resistance between any two corners. Okay. So for this I have to need some places. Yeah. Okay, need some places. Okay. Need some places. So 3 2 ohm resistors are connected to form a triangle. This is 2, this is 2 and this is 2. Equivalent resistance between any two corners. So if we apply EMF at these 2 points, corner A and B, current flowing in this way, this is I, this is I1, this is I2. So I1 current flowing these two resistors, so same current flowing these two resistors. Okay, this and this. So these two resistors are in series. So circuit becomes, this is 2 2 in series R1 plus R2, this is 4, and this 2 is in parallel. Okay, this is 2. So equivalent resistance between these two circuit will be R equivalent one second, 18 by 6 na 10 by 6, 8 by 6, 8 by 6. This is 4 by 3 things. Equivalent resistance between two circuits. So this is 4 and this is 2. So 8 and this is a 4 by 3, answer will be 4 by 3. Just easy question. When we attach a electromotive force EMF and current flow, same current flowing between two resistance same, and different current flows this resistor. So these two resistors are in series, and that's easy question. Just series and just these two resistors are in parallel. So this is the answer. 16 gram oxygen gas and 6 gram hydrogen gas occupies the same volume at same temperature at pressure. Okay. The values of X. 16 oxygen and 6 gram hydrogen gas occupies the same volume at same temperature and pressure. The values of X is. Okay, from ideal gas equation we can write this PV is equal to nRT. Okay. So N is equal to PV by RT. Okay. In my question, given that 16 gram oxygen and 6 gram hydrogen gas occupies same volume, so volume of two gases same volume, are remains at same temperature and pressure and temperature of two gases same, so their mole number will be same. Okay, good. So mole number of oxygen in O2, mole number of hydrogen will be same, right? So mole number means mass by molar mass. So here 16 gram oxygen present, so 16 by molar mass 32, and x gram hydrogen present, so x by 2. So from this equation x is equal to 1. Okay, x is equal to 1 gram. The value of x is 1 gram. From this ideal gas equation we can write this. Okay. As the two gases occupies the same volume and pressure and temperature of these gases are same, then this mole number of two gases will be same, and just from this equation we can solve this. So electromagnetic theory suggests that light consists of, there is a 4 options are present, but answer will be electric. We always know that from class 10 that electromagnetic theory says that electric field and magnetic field, for electromagnetic wave, electric field and magnetic field always perpendicular to each other. Okay. Electric field always perpendicular to magnetic field. Good. A Carnot engine working between the temperature 300 Kelvin and 600 Kelvin has work output of 800 joule per cycle. The amount of heat energy drawn from high temperature source in each cycle. Okay, again I read this question. A Carnot engine working from question from thermodynamics. Temperature working between temperature 300 and 600 Kelvin has work output of 800 joule per cycle. Amount of heat energy drawn from high temperature source. Okay, the Carnot engine is like this, na? This is a machine. This is source. This is sink. This is Q2, this is T1, this is T2. Okay, temperature of the source is T1, temperature of the sink is T2, and machine works W is equal to Q1 minus Q2. Good, this is the Carnot engine. Q1 heat drawn from high temperature source and Q2 heat flows through to the sink. Okay, and work done by the engine by machine is Q1 minus Q2. Okay, which is work done is equal to 800. The question is given. Okay, so W is equal to 800 given. So I need in joule. I need some more places, na. So sorry for this. I need some more places. So okay, I think this is sufficient. Q1 minus Q2. So and Carnot engine, one important rule is Q1 by T1 is equal to Q2 by T2. So Q1 heat coming from source or drawn from source. So Q1 by Q2 is equal to T1 is equal to 600. The heat is higher temperature. Heat has higher temperature and source has higher temperature. Source from source Q1 heat coming to the machine and Q2 heat flows through the sink. Source has a higher temperature T1 600 and sink has a lower temperature 300. So this is 2. Okay, and I have to find amount of heat energy drawn from high temperature source. So we have to find out Q1. Okay, and also W is given. We know Q1 minus Q2 is equal to W. So Q2 is equal to Q1 by 2, 800. So Q1 is equal to 1600 joule. Okay, from this formula Carnot engine we know that source has higher temperature T1, sink has lower temperature T2. From source Q1 heat is coming to sink, to the sink Q2 heat is going, and machine works done W is equal to work done by the machine W Q1 minus Q2 from this formula. And this important formula is a Q1 by T1 by Q2 by T2. Q1 is the heat coming from source and Q2 heat going to sink, and T1 is the temperature of the source and T2 is the temperature of the sink. From this lesson we can solve this. Okay, this question you have to find out Q1 only in this question. Good. Next question. A particle moves in such a way that the acceleration a is equal to minus bx, where b is constant and x is the displacement from equilibrium position. Okay, the time period of the oscillatory motion of the particle. Okay, good. Particle moves in such a acceleration a is equal to minus b. So this is like simple harmonic motion. Okay, for a simple harmonic motion acceleration a is equal to minus omega square x. Omega is a frequency. From these two equations I have to compare. Okay, so omega square is equal to b and omega is equal to root over b, and omega is equal to 2 pi by t root over b, and t is equal to 2 pi by root over b. So such way acceleration minus or b is the constant displacement between position. Okay, so it's a displacement, we have to find a time period. Okay, this time period is a t 2 pi root b. This simple question, just we have to match this acceleration to simple harmonic motion. Okay, for simple harmonic motion a is equal to minus omega square x, here omega square is equal to b. From this equation we have to calculate the time period. Okay, this is oscillatory motion, and this acceleration is like simple harmonic motion. So I took this, I just match these two equations. Okay, next I have few chemistry type questions. Be honest, I forget many knowledge about chemistry. I have no knowledge about chemistry now, but I think few questions, some comes are basic questions from chemistry are given. Okay, few basic questions are present in the paper, so I took this from. So first question is, which among the following is the best conductor of the electricity? Conductor means poribahi, sorry, conductor of electricity. Filtered hot water or distilled water, filtered water at room temperature, and saline water. Saline water means labanakto. In saline water in Bengali language, saline water means labanakto jal. Okay, so we know knowledge basic. This is not in basic knowledge. Saline water is the best conductor from among these. Okay, among these. And another basic question is, among the following compounds, which one has the zero dipole moment? Okay, from their structure. Okay, I remember from the structure you can easily say that which has zero or non-zero dipole moment. From NH3, sorry, one thing I think wrong. Sorry. NH3 structure is given na. M, this is H, and N is more electronegative than H, so electron go like in this way, bond electron goes like in this way, so net dipole moment is not equal to 0. Okay, for is to from structure you can easily say that. In class 11 I think this type of things are present. Oxygens are more electronegative, so bond electron goes in this way, not goes, but electron affinity is more oxygen than hydrogen, so dipole in this way not equal to 0. And CCl4, tetrahedral, carbon, chlorine, so chlorine is more electronegative than carbon. So we see that net dipole is 0 na, net dipole moment is 0. Here chlorine is more electronegative than carbon, so bond electron goes to more about in chlorine. Okay, bond electron goes towards chlorine more, so this and these two dipoles cancel each other, and again these dipoles cancel each other, so total dipole moment is 0. And another option is HCl also not has possessed a dipole moment, because HCl, chlorine has more electronegative, bond electron more goes towards the chlorine, so dipole moment again not equal to 0. But here for CCl4, one thing, CCl4 tetrahedral structure, chlorine is more electronegative, so this dipole, this cancel each other, so total dipole moment is 0. So CCl4 will be answer. The basic question, CCl4 is the answer. Okay. Another basic thing is that the number of electrons required to balance the following reaction. Okay, so there is no ion present in the right side and there is an ion present, so we have to balance how to balance this. So the balancing condition, NO3 minus, N5 plus, and oxygen 3 minus 6. Oxygen NO3 is basically this, N5 plus and 2 minus, so 3 oxygen, so 5 minus 6, this is minus 1. Okay, so there is minus 1 ion present, Here plus 4 proton present, so total number of positive charge here, positive ion present plus 3, and here no ion present, so this plus 3 will be cancelled by this minus 3 electron. Okay, so if this there is no ion, there will also be no ion, so we can say the balance. Okay, so there are plus 3 ion positive charge is present, also there are 3 negative electron ions to balance this equation. Okay, so this option will be 3. This question is some basics. Yeah, you have to know, not know any formula or any thing, just to know the basics. We have to solve these questions, this and also this question. And one question, I think this is the last question. Okay, a bullet of mass 25 gram moving with a velocity 200 centimeter per second is stopped within 5 centimeter of target. The average resistance offered by the target. Okay, this is the bullet, this is the target, and bullet stops within 5 centimeter from the target. Okay, when it enters the target, its velocity is u, and when it stops, its velocity is v. Okay, so you know that v square is equal to u square minus 2as. We use this formula, and a is the deceleration here, not acceleration. And after 5 semi in the target, final velocity will be 0, and when entering the target, initial velocity is u, so u square minus 2as, so a is equal to u square by 2s, and u is equal to 200 centimeter. Na? 200, sorry, one second. If I write in SI all this equation form, 1 meter 100 centimeter, so 200 means 2 meter. Okay, 2 meter square, and second means time is time. No, sorry. One thing, v square equal to u square minus 2as. S is the distance up to which distance the bullet goes through the target. Okay, so S is 5 semi. So this is 5 semi means 5 by 100. So this is 2, this is 0.05. So 200, this is 40 meter per second square. Deceleration, not acceleration. Okay, and the average resistance offered by the target will be, this is average resistance offered by the target will be m into a, m mass of the bullet mass 25 gram, so 25 by 1000 into a 40. Na? So this is 1 Newton. Average resistance offered by the target is this 1 Newton. This is the question. Firstly, we have to find out the deceleration of the bullet. Up to 5 semi, bullet rests, the bullet stops, not rest, bullet stops, and then we calculate the average resistance offered by a target, which is ma. A is the deceleration. So I think no questions remain from physics part only of Wbslst 2025 question paper. Okay, so good, so done. So if you are preparing for competitive exams, make sure to follow my channel, and don't forget to like, share and subscribe my channel. Okay, for more detailed solution. So bye.